Hi, I am Pranay. Welcome to our video series on operating system. In this video, we will cover introduction to process in memory, sections of a process in memory, command line arguments, text, data, stack, heap, program counter, and register. In the next part of the video, we will show the demonstration with the programming using array and pointer. Let's continue the video. Introduction to process in memory. Definition of process. A process is an instance of program that is currently being executed. It encompasses several key components, program code, the set of instructions that the program is running, program counter, a register that holds the address of the next instruction to be executed, program register, the whole intermediate data and address used by the CPU during execution. Process memory. The allocated memory regions using by the processors. Processors are essential for operating system because they enable multiple programs to run simultaneously by providing structure approach to process, creating execution and termination. Importance in an operating system. Processors are vital to the functioning of an operating system for several reasons. Resource management. Processors help the operating system efficiently manage all the allocated system resources such as CPU, time, memory, and devices. Concurrency. By supporting the concurrent execution of multiple processes, operating system improve overall system performance and responsiveness. Isolation. Processes maintain separation between different programs, which prevents one process from directly interfering with another, thereby enhancing system stability and security. Communication. Through various interprocessor communications (IPC) mechanism, processors are exchanged, informed, and coordinated their activities, enabling more complex and cooperative functionalities. Basic concept and structure of a process in memory. When a program is executed, it transforms into a process and is loaded into memory. The operating system allocates specific memory region for different aspects of the process. The typical structure of a process in memory includes the following sections. Command line argument. These are the parameter passes to the program at execution time, influencing its behavior. They are stored in a memory and accessible to the process. Text code section. This section contains the executable code for the program. It is often set and read only. It prevents the accidental modification during execution. Data section. This area holds global and static variables that have been installed by the programmer. These variables persist for the lifetime of the process. Stack, used for managing local variables and function calls. It dynamically grows and shrinks as function as invoked and returned. The stack maintains the execution context including parameters, return address and local variables. Heap, reserved for dynamic memory allocation. The heap allows a processor to request additional memory as needed during runtime. Memory allocated on the heap remains until expli- explicit delocation by the program. Program counter holds the address of the next instruction to be executed. It is crucial for controlling the sequence of instructions executed and executions. Register status are fast, small storage locations within the CPU. The register status reflects the current value stored in the registers, facilitating quick data manipulation and the retrieval. The operating system oversees the section and manages the process through various states. This management ensures efficient use of resources and maintains the system stability. This is the second part of the video. Sections of processes in memory. Command line argument. The command line argument are parameter passed to a program when it is executed. They allow users to influence the behavior of the program by providing input values or options at startup. Description. In many programming languages, command line arguments are passed to the function of the program. For instance, in C or C++, the main function is typically defined as following, which which I'm trying to circulate properly. This is the command line. ARGC, argument counter, represents the number of command lines arguments including the program name. ARGB, argument vector, an array of a string where each element represents a command line argument. ARGB ARGB 0 is the name of the program, while ARGB1, ARGB2, etc. are the actual argument passed to the program. Example: if a program named example is running with the command line example arg1, arg2, argc would be the third line. Argv would be an array containing usage. Command line argument enable the customization of the program execution without altering the code. For example, a program designed to process file might use command line argument to specify the file name to the to be processes. Text code section. The text code section can contain the compiled executable code of the program. It contain it consists of the instructions that the CPU executes. The description. The text section is typically marked as read only to protect the code from being altered during execution, which helps maintaining code integrity. It is loaded into memory from the executable file when the process is installed installized. Data section. The data section holds global and static variables that have been installized by the programmer. The description. The data section is divided into two parts: installized data and uninstallized data. Installized data contains global and static variables with explicit initial values. Uninstallized data includes global and static variables that are not initialized explicitly by the program. These variables are automatically sent to the zero by the operating system before the process starts. The variables remains in memory for the entire duration of the process. The stack. The stack is used to manage local variables on the handle functions call. It keeps track of the function execution by storing parameters, return addresses, and local variables. Description: the stack grows on strings dynamically as functions are called on return. Each function invocation creates a new stack frame, which includes the function's local variables and other data necessary for managing the function call. Heap. The heap is used for dynamic memory allocation. It allows the process to request and release from memory during runtime based on its need. Description: the heap grows on strings as the process allocates and delocates memory. It is managed through functions such as malloc and free. In C or C++ or new and delete in C++. Program counters. The program counters hold the address of the next instruction to be executed by the CPU. Description: this PC is crucial for ensuring the instructions are executed in the current sequence. It is updated after each instruction is fetched and executed, moving to the address of the next instruction. Register status. Registers are fast small storage locations within the CPU that hold data and addresses using in executing instructions. Description: the register status includes the current values stored in CPU in all CPU registers. Registers provide rapid access to frequently used data and are integral to performing arithmetic operations, managing memory access, and executing instructions efficiently. Understanding these sections and their roles is key to grasping how process is organized in memory and how the operating system oversees its execution. The foundation knowledge is essential for delving into advanced topics such as process management, memory allocation, and system performance optimization. Command line arguments. The role. Command line arguments are parameters provided to the program at the time of its execution. They enables users to influence the behavior of the program dynamically without alerting the source code. Description: command line arguments are typically accessed via the main functions in many programming languages. In C or C++, the main function is often defined as the following: int main as this. ARC argument counter represents the number of command lines arguments passed to the program, including the program name. Stack. The stack manages local variables and functions call. It tracks from execution local variables and control flow. Description: the stack operates on a last in first out principle. Each function call generates a new stack form, which includes the function local variables, parameters, return address, and other control data. When the function completes its stack form is removed and control returns to the calling function. The stack dynamically adjusts in size as following are called return. Example: in the following function, this is the function. When FOO is called, a stack form frame for FOO is created. If FOO call bar, a stack form for bar is added to top of the stack. After bar finishes execution, it Stack for after bar finishes execution, its stack form is removed and control returns to FOO. Heap. The heap is used for dynamic memory allocation, allowing programs to request or release memory as needed during execution. Unlike the stack, the heap does not follow LIFO pattern. Memory can be allocated and freed in any order. The heap is managed using functions like malloc, call OC, recall OC, and free. In C or C++ or new and deleted in C++, memory allocated on the heap remains in use until deallocation by the program. The allocation an array of integrates at runtime. In this FREE array, deallocated memory when done. In this example, malloc allocates memory from the array of the heap, and free deallocations it and free deallocates it when it is no longer needed. The example of register status. Consider a basic additional operation in assembly language. Assembly MOV R1 hash 5. Load the value 5 into register 1. MOV R2 hash 10. Load the value 10 into register R2. ADD RO R1 R2. Add the values in R1 and R2 stores the results in RO. R1 and R2 are generally purpose register holding the operands. RO stores the results of the additional operations. As these instructions are executed, the value in the registers are updated to reflect the current state of computation. Understanding the functions of the PC and register status is essential for grasping how a CPU manages and processes instructions as their components, directly impact the execution flow and data handling within processor. This is the end of the part 2. In the next section, I will explain the part 3. I will explain the demonstration with the program using an array and pointer. Thank you for watching my video. Please share, like and subscribe. Thank you.